Okay, so I'm going to go through and do some of the problems. I'm not going to do any of the fill in the blank ones with the words. I think that's something that you can work on your own. The first actual question comes down here, and it says determine the coordinates of the indicated point on the graph. And so the first one wants me to look at C. And so to get to point C, what I would do is I would go 0 in the x direction, right? I would stand right here at the origin, that's where x is 0, and I would go straight up 2. And so the solution to number 11 is 0, 2. Then for point B is way over here, so if I were to move to point B, I would have to go this direction, which is the x direction, the first coordinate, -3, and then I would have to move up 4 units. And so my solution there would be -3, 4. And then last but not least, we have G, which G is all the way over here. And notice for point G, to go to point G, I'd move -3 in the x direction. But since I'm not going to move vertically, meaning I'm not going to move up and down, that means the y coordinate is 0. So just make sure that you can read points. All right, the next question says complete the ordered pairs for the given equation. So basically they give you the values of x, because remember, ordered pair, it always is ordered alphabetically so that x comes before y. So what I can do here is I can just simply make a table, and in that table I'm going to go ahead and fill out the given values of x that they give me. And so make this table all pretty. So they give me 0, 1, and -1. The y value is achieved by taking the x value, doubling it, and adding 1. Meaning that the y value is going to be 2 times whatever the x value is plus 5. So all I have to do is come in here and substitute. So here I'm going to do 2 times 0 plus 5, 2 times 1 plus 5, and 2 times -1 plus 5. And so when I plug in 0, 2 times 0 is 0, 0 plus 5 is 5. And so what this tells me is that this point right here is the point 0, 5. So we're looking for these values. So when x is 0, y is 5. Then when x is 1 and I plug it in, 2 times 1 is 2, plus 5 is 7. So this value would be 7. And then here, 2 times -1 is -2 plus 5. That would actually be 3. So now I've got points to plot. The first point I'm going to plot is 0, 5. So that point would be right here, because you don't go left or right, you just go straight up 5. The next point says 1, 7. Well, I'm going to go over 1, but I don't have 7 quite there, so let's just fudge it. And then the last point I have here is -1, 3. So over -1 and up 3. So now I've got my points, or my dots, my points, I'm sorry, and I can connect them with a straight line. All right, so that's how you do number 14. Number 15 and 16 are special linear equations. When I look at an equation like this means the y coordinate is always -5. So when I look at this equation here, it's telling me the y coordinate is always -5. So let's move this over a little bit. So let's think about a point where the y coordinate is always -5. Well, right here. If you look at that point, that's the point, let's see, 0, -5. But I can also pick a bunch of other points. For example, here's the point 4, -5. Or you could have picked the point right here and said 1. I'm kind of overkilling it here, guys, but that's 1, -5. Or you could have picked a point over here and said -2, -5. But the main thing is every single one of these y values that I'm looking at is -5. And so if you notice, if you connect these dots, you're going to get a horizontal line. Now, obviously, I can't stand for that. But you're going to get a horizontal line through that y value of -5. Now, the next one says x equals 3. Well, that means the x coordinate, which is the first coordinate, is always 3. So, for example, this point right here, this point right here, this point right here. I'm not going to do any more, but that's oops, I almost messed up. That's 3, 0. This is 3, 1. Go over 3 and down 3. And so what you end up having here is a situation in which the x coordinate is always 3. And when we have that, we get a vertical line through that x coordinate. Ooh, that was good free-handed. Cool. I still want it nice. So if you can remember how these work, if it's x equals a number and you're graphing or y equals a number and you're graphing, it's only when the equation, like the one above, had x and y in it, right? Y equals 2x plus 5, that we got a slanted line. But if it just has y or if it just has x, it's either going to be horizontal if it has y equals and vertical if it has x equals. All right, number 17 has to do with the x and the y intercepts. So if I come up here back to my definition page, this is kind of important. One of the things that it has to do with this in the definition is x-intercept and y-intercept. And so the thing about an x-intercept, an x-intercept is a point where the graph crosses the x-axis. So if you have the x-axis here and the y-axis here, so again, the vertical number line is the y-axis, right? And the horizontal line is the x-axis, so that helps me there. An x-intercept, kind of hard to fit in there. An x-intercept is a point on the graph where the graph crosses the x-axis. So that would be like this point here. Or it could be over here, or it could be here. And the thing about these points, guys, is that every single one of these points, I don't know, whatever the x value is, the x value is, but they all are going to have a y value of 0. So, for example, if I just looked at this point right here, I don't know how far over I go in the x direction, but I can tell you that I don't go up or down at all. So to find an x-intercept of a graph, you're going to let y equal 0. Now, the other one would be your y-intercept. I don't care where it's at. If you put a dot anywhere on the y-axis, then that means that that point is a y-intercept. And wherever that point is, the x value is 0. So that's what's going on with those questions right there. Now, on number 17, it simply wants me to identify. So here, if I identify the x-intercept, that's going to be this point right here. And that's the point -2, 0. This point is the y-intercept. And if it's a y-intercept, then I know x is 0, and that y value is 4. So that's all you're doing on 17. All right. Number 18 says to graph the linear equations by finding and plotting its intercepts. Meaning, I'm going to scroll down here for just a second to give myself some space. The equation is -3x minus 15y equals 15. And so to find the x-intercept, you're going to let y equal 0. So notice if you let y equal 0, then you end up with just -3x equals 15. So if you look at this equation here, basically, if I let y equal 0, then that's essentially saying, hey, just ignore that. Not ignore it, but 0 it out. And when I 0 that out, I can clearly see that x has to be -5. Or I can go through the process of solving it and getting that x equals -5. So when we let y equal 0, x equals -5. So that's the point, -5, 0. If I want to do the y-intercept, for the y-intercept, we're going to let x equal 0. So in this equation, I'm now going to let x equal 0. And so just like before, if I let x equal 0, then I'm just going to be left with minus or -15y equals 15. So when I let x equal 0, I'm going to get a y value. Well, if we divide both sides by -15, I'm going to get that y is -1. So when I let x be 0, y was -1. To me, this is the long way of graphing using intercepts. If you have a situation like this problem, I'm going to go back up to this problem. If you have a situation like this one, hold on just a second, let me do something. And you're doing the intercept technique, first of all, notice that the coefficients here will divide into this number over here. If that's the case, then I just simply make a quick little table, and I'm going to put 0, 0. So for the first one, if I let y be 0, if I let y be 0, then I'm just looking at this equation. And so I think, well, -3x equals 15 tells me that x equals -5. So there's my point, -5, 0, which would be right there. Then I go back and I say, okay, if I let x be 0, this goes away. And so that means I have -15 y equals 15, so y equals -1. And so that would be the point down here at 0, -1. And so that's just a quick way of doing the steps so that I'm not, going through this whole long process here. Okay, so what I should have done, and I'm going to do it now, let's see. So numbers 19, 20, 21, and 22 have to do with slope. So if you're supposed to find the slope that passes through 2 points, you're going to use the formula m equals your second y minus your first y divided by your second x minus your first x. And so in this problem here, I like to think of this as x1, y1, x2, y2. And so you can almost think of it as, just plugging in little numbers here. So I'm going to be plugging in, let's see, plugging in there and there, and then there's my x2, and here's my x1. And so if I just compare, the second y is -4 minus the first y, which is -5. And then the first x is 2 minus the second x, which is -2. Sometimes you'll see people put parentheses here, right? That's a very common thing to do. So whenever you subtract two numbers, you are really adding the opposite, meaning I'm taking -4 and I'm adding to it a +5. And I'm taking 2 and adding a +2. I like to call it keep, change, change. But taking away a negative is addition. And so what I get out of this when I combine my terms here is 1/4. So that's how you can find the slope of a line given 2 points. You can also find the slope using a graph, because remember, slope is exactly what this is. It's the difference in two y values over the difference in two x values. So you could pick any 2 points you want on a graph. I'm going to do something different first. So what we just did was we looked at these 2 points. And so one thing about this line right here, if this were the line that I was given, so let's say I was given this line, I would want to find 2 nice points. So just hang with me that those were nice. And you would just count. You would say, okay, to go from my left point to my right point, I would rise 1 block. So I'm counting the number of blocks. I'm not saying 1, 2. I'm just going 1 block high, and then 1, 2, 3, 4 blocks to the right. So the slope there is 1/4. So all you have to do is find 2 nice points. And so basically what I did was I took these points here and I plotted them there and there. So if you have a graph, you're just going to find 2 nice points. I don't care where they are. So let's say I was looking at this graph and I saw the points, maybe this point and this point. Well, then what I would notice is that I would have to go down 2 blocks. You see how that's 1 block, 2 block, but I went down. And then 1 block, 2 blocks over. And so that means my slope would be -2/2, which actually equals -1. Now the cool thing about slope is you could have picked anything you wanted. So let me take this off here for a second. So you could have picked anything you wanted. You could have picked these 2 points. You would have gone down from left to right, 1, 2, 3, 4 blocks down, and then 1, 2, 3, 4 blocks over. But -4 divided by 4 is still -1. So you could have done a variety of ways. You just want to pick those nice points. All right. Now, 21 and 22 to me are just memorized ones. The slope of a horizontal line is always 0, and the slope of a vertical line is always undefined. The reason is simply that it's okay to pick 2 points here, and it's okay to notice that I don't have to rise at all. So my slope would be 0/, and then in this case I picked 4 blocks to run, but it doesn't matter. How many blocks you pick to run, 0 divided by a number is 0. Whereas over here, if I pick 2 points, just 2 random points there, here my slope would be to rise 2 points, or 2 blocks, I'm sorry, but to run no points. And dividing by 0 is undefined. So that's what's going on with 21 and 22. But this is always true for a horizontal line, and this is always true for a vertical line. All right, the last one on this grouping, slope-intercept form to graph the equation. So what you're going to do with the slope-intercept form is you're first going to look at the equation, and you're going to identify m and b. So when you have y equals mx plus b, here my b equals 3 and my m equals -1/3. So your first step is you're going to start by putting a point on the y-axis at the value of b. Value of b, which would be here. And then you are going to use rise over run, which is which is your slope, to move to a second point. meaning you are going to, in this case, you are going to move down 1 block and right 3 blocks from that point we just plotted. So I'm going to start at this point that I plotted on B, the y-intercept, and I'm going to go down 1 block and right 1, 2, 3 blocks. And that's going to give me my second point. And then once I have that second point, that's enough to draw the line between those 2 points. And there you go. So that takes care of all the plotting points and graphing and all that. If I go back real quick, because we kind of did talk about this. A solution, that's the ordered pair that makes the equation true. A linear equation can be written in this form, which that's technically called standard form for a linear equation. Whereas this type, y equals mx plus b, that's called slope-intercept form. And then last but not least, the slope of a line measures its steepness or tilt. All right, so there we go.